You ever just stop and think about how wild it is you can walk into a room and just get it? Like, you've been there, you recognize people, you can follow the conversation.
Yeah, it is pretty amazing when you think about it. Our brains are constantly pulling from this huge memory bank to make sense of everything.
It's all thanks to memory, right? And not just one type. We've got that super quick sensory memory, then short-term memory like a mental notepad, and then this massive long-term memory. It's mind-blowing.
Absolutely. Long-term memory is where we store everything, specific events like that crazy party last year, general knowledge like who's the president, the skills we've learned, even emotional stuff. It's all in there somewhere.
And we can't forget context, that whole when and where thing. It's how we actually learn and understand the world around us. But here's the thing, we're diving into how large language models, or LLMs, are trying to do the same thing.
Yeah, and it's a huge challenge for them. LLMs are incredible at language tasks, but replicating that deep contextual understanding we humans have, that's a whole other ballgame.
What's the main roadblock for them? I mean, they're so smart in so many ways.
Well, one big one is the context window. Think of it as their version of short-term memory, and it's pretty limited compared to ours. This means they can only juggle so much information at once. So conversations with LLMs can sometimes feel a bit disjointed. It's like they're forgetting what you just said a few sentences ago.
And I guess that also plays into those hallucinations we hear about, right? Where they just make stuff up.
Exactly. That limited context can lead to them generating inaccurate information. It's all connected. But researchers are working on ways to give these LLMs a better memory, and get them closer to that human-like understanding of context.
And it seems like they're actually looking to our own brains for inspiration, like how our episodic memory works for remembering specific experiences and semantic memory for general knowledge. So how are they doing this, making these LLMs remember better?
Well, one approach is pretty straightforward. Just make that context window bigger.
So they can just hold more information at once.
Yeah, kind of. And techniques like positional interpolation are being used to help the model understand the order of words, even in those super long sequences. But it's not a perfect solution.
Right, because just cramming more information in doesn't necessarily mean it's going to be processed or remembered accurately, does it?
Exactly. It's like if you're trying to remember a whole shopping list at once, you might start mixing things up or forgetting items. There can be trade-offs in efficiency and accuracy across that larger window. It's a balancing act.
So what else are they doing? What about giving them a whole separate memory bank?
That's another promising area. They're called memory networks. These essentially give LLMs an external place to store and retrieve information that's outside of their immediate context window.
So like a long-term memory they can tap into.
Exactly. Examples like Camelot and Larimar are showing how we can give LLMs more persistent memory. It's a big step toward more coherent and contextually aware interactions.
That's cool. So they're not just stuck with what's right in front of them. What about something like giving them access to a giant library of information?
You're talking about retrieval augmented generation, or RAG. Imagine giving an LLM access to a vast collection of data like vector databases and knowledge graphs.
So like when it's asked a question, it can search for relevant information first and then use that to give a better answer.
Precisely. It's like giving them the ability to fact-check themselves and pull in more context before responding. This has been a game changer in improving the accuracy and depth of LLM output.
That makes a lot of sense. But you mentioned earlier that researchers are taking inspiration from how our own memory works. Are there any approaches that really try to mirror that?
Absolutely. When it comes to episodic memory, EM-LLM is a fascinating example. It tries to segment information into distinct events, sort of like scenes from a movie.
Oh, so like how we remember specific moments or experiences from our own lives.
Yeah, exactly. And then it retrieves these events based on similarity to the current situation and also when they happened. It's about recreating that sense of temporal context, which is so crucial for how we understand narratives and experiences.
That's super interesting. So it's not just what happened, but when it happened. It all adds to the meaning.
Right. And early results show that this kind of event-based memory retrieval can actually outperform just expanding the context window. It suggests that LLMs might benefit from organizing information more like we do in terms of these episodic chunks.
That makes sense. And what about semantic memory, our knowledge of facts and concepts? Are there approaches that are trying to replicate that aspect of human memory?
Definitely. There's a lot of exciting research on semantic memory networks. Think of these as trying to build a detailed map of knowledge, organizing it hierarchically, like a giant family tree of concepts.
So like how we understand that a cat is a type of animal, which is a living thing, and so on.
Exactly. It's about building those relationships and connections between different pieces of information, and it often involves integrating those knowledge graphs we talked about earlier. It's a complex process, but essential for giving LLMs a deeper understanding of the world.
It's fascinating how much of our own thinking and understanding relies on this interconnected web of knowledge. And one thing we humans do really well is forget things. Is that something researchers are looking at with LLMs? I mean, it sounds counterintuitive, but it seems like there might be benefits to forgetting for these models too.
You're absolutely right. Just like our brains don't hold on to every single detail, there's growing interest in enabling adaptive forgetting in LLMs. This means allowing them to shed less relevant information over time.
It's like cleaning out the mental attic and making space for new memories, right?
Exactly. And it can make memory retrieval more efficient and prevent those models from getting bogged down with outdated or irrelevant stuff. But it's tricky because we don't want them to lose important knowledge. There's a lot of work being done on techniques to mitigate catastrophic forgetting, which is when learning something new completely wipes out old information.
I can see how that would be a problem. So, pulling this all together, where do you see this all heading? What's the ultimate goal with giving these LLMs a memory system more like ours?
Well, the big picture is to bridge that gap between memory and contextual understanding, to get these LLMs to a point where they can process and respond to information in a way that feels truly human-like.
So like having a genuine back and forth conversation where they remember what you've talked about before and use that to inform their responses.
Yeah, exactly. And different types of memory play a crucial role in that. Episodic memory, for instance, could allow for much more personalized and contextually relevant interactions. Imagine an LLM that remembers your past preferences or conversations and uses that to tailor its responses. That's a whole new level of personalization and engagement.
That would be incredible. And what about semantic memory? How does that contribute to this big picture of contextual understanding?
Well, semantic memory is like the foundation. It's the world knowledge, the facts, the concepts that allow us to interpret any situation. Without that, even the most sophisticated episodic memory would be limited.
Because you need that general knowledge base to make sense of specific experiences, right?
Yeah,
Like understanding cultural references or the background of a news event.
precisely. And this highlights why an integrated memory system where these different types of memory work together is so crucial. It's not just about remembering more, it's about remembering in a way that allows for true understanding. And that's what we're striving for with LLMs, to get them to that level of human-like comprehension.
It sounds like we're making some real progress. But I imagine there are still some pretty big challenges ahead.
Oh, absolutely. One of the biggest is the computational cost. These advanced memory systems, especially when we're talking about huge knowledge bases, can require a lot of processing power. Figuring out how to scale these systems effectively without breaking the bank is a major hurdle.
Right, because if it takes a supercomputer to run these models, that's not exactly practical for everyday use.
Exactly. And then there's the challenge of evaluation. How do we even truly assess whether an AI's memory and understanding are genuinely human-like? We can measure performance on specific tasks, but capturing those subtle nuances of human comprehension is a whole other problem.
It makes you wonder, as we develop these increasingly sophisticated AI systems that can remember and learn from their experiences in a more human-like way, how will our interactions with them change? What new possibilities might emerge?
That's the big question, isn't it? And it's not just about the positive possibilities. What about the potential downsides? Could these AI systems develop biases based on what they remember? Could they be manipulated through their memories? These are questions we need to grapple with as this technology continues to evolve.
It's a lot to think about. As we create AI that can remember and learn like us, we also have to consider the ethical implications. How do we ensure these systems are used responsibly? How do we protect privacy and prevent misuse? These aren't easy questions, but they're crucial to address as we enter this new era of AI development.
It's a brave new world, and memory is at the heart of it all.
It really makes you wonder what the future holds. As AI develops these more human-like ways of remembering and understanding, our world could change in ways we can't even imagine. It's exciting and a little bit daunting to think about what lies ahead.
Absolutely. It's a journey full of possibilities and challenges, and it's just beginning.